Hi, it's Graham Cox here, co-founder of OptiSurface, and I just want to take you through this example case study field, which is in Nevada. It's a center pivot growing alfalfa and winter wheat. The problems the client was having was that there was many low spots and high spots causing ponding and runoff issues, as well as increased disease and pest pressure in the low spots. Here's the existing topography. There's the highest area there, there's the lowest area there. The color bands are 1.5 feet apart. So from top to bottom we're looking at about 10 feet of fall over about 2,400 feet or 800 meters. We can run our drainage analysis over the top of that existing topography, and it shows us the ponding areas with the depth of water and also the flow paths and this is represented by the catchment area here. So as you can see, this area here is a depression, and that's represented there. So you can see there's probably only 5 or 10% of the field that's got depressions in it, but that causes problems for the whole field in terms of getting on the field to do operations when you want to do it, as well as drowning those areas out. The other critical part about center pivots is that you don't want water to run off where you apply it. And as the slope increases, then you've got more likelihood of water running off, especially around the outside of the center pivot, where the instantaneous application rate from the center pivot is the highest. So OptiSurface landforming has two purposes here. One is to increase the minimum slope so there's no depressions, and reduce the maximum slope to reduce the chance of runoff, and also smooth the field out so that you have a more uniform infiltration and machinery operations. So this is the proposed surface. So that's the existing, and then this is the proposed. So you can see how it's changed. The contours have become more uniform, and then you can see each one of these grid points, which is about 30 foot apart. The elevation of those is optimized to our requirements. So the main inputs to the design process were the surface type. OptiSurface 4-way was used to design the field. This surface type allows water to flow across the field and exit to the boundary. And then the minimum slope was 0.1%, which is slightly higher than our 0.05% that we go down to in some cases, but we find in center pivots the wheel tracks can create small ridges that restrict surface drainage. So we've pushed this minimum slope up a bit higher. The maximum slope is 1%, and as I stated before, that's to try and limit the likelihood of runoff. And the smoothing was 300 foot per percent. Here's the cut fill map, which is basically just the subtracting the proposed from the existing surface. And as you can see, there's cut areas here that are greater than 1 foot, and there are only one fill area where it's greater than a foot of fill. So in conclusion, we ended up with a design that required 177 cubic yards of material to be moved per acre. This is equivalent to 334 meters cube per hectare. And we checked in with the client after he'd finished the job, and he had these comments. He said, "The field is finally coming in with some winter wheat and it looks terrific. We're so pleased with the way it came out. No more ponding, damping off, salt accumulation. The water goes in as evenly as it goes on. This is a completely different field." And there's Mark standing in front of the field after it's been replanted with alfalfa. You can see it looks generally flat to the naked eye. However, there is a slight slope on that whole field to make sure that it drains nicely. Thanks for watching. And if you haven't seen what OptiSurface can do for you yet, please go to our website and click on the big orange button to get a demo field design, or have a chat with one of our Earthworks experts to see how OptiSurface can help you. Thank you for your time.